Consider three vectors, A bar, having a magnitude of 2 units, and directed at an angle of 30 degrees from negative x-axis in third quadrant, and is pointing down. B bar, which is having a magnitude of 2 units, and is directed at an angle of 30 degrees from y-axis, and is in fourth quadrant pointing downwards. And vector C bar, having a magnitude of 5 units, which is in second quadrant, and is directed at an angle of 60 degrees with x-axis, and pointing upwards. Find the vector sum of the three vectors. How do you solve this problem?
First, I will draw all the three vectors with the given data. First, vector A bar has magnitude of 2 units, is directed at 30 degrees from negative x-axis, is in third quadrant, and is pointing down. Next, vector B bar has magnitude of 2 units, is directed at 30 degrees from y-axis, is in fourth quadrant, and is pointing down. And last, vector C bar has magnitude of 5 units, is directed at 60 degrees from x-axis, is in second quadrant, and is pointing up. Then I will calculate the angle made by each of the vector with positive x-axis. Here, vector A bar makes an angle of 180 degrees plus 30 degrees, which equals 210 degrees, with positive x-axis. Similarly, vector B bar makes an angle of 270 degrees plus 30 degrees, which equals 300 degrees, with positive x-axis. Finally, vector C bar makes an angle of 90 degrees plus 30 degrees, which equals 120 degrees, with positive x-axis. Therefore, vector A bar makes an angle of 210 degrees, vector B bar makes an angle of 300 degrees, and vector C bar makes an angle of 120 degrees, with positive x-axis. Now using the formula, V bar is equal to V cos theta times I hat plus V sin theta times J hat, where theta is the angle made by the vector with positive x-axis, I get vector A bar is equal to 2 cos 210 degrees times I hat plus 2 sin 210 degrees times J hat, which equals minus 2 cos 30 times I hat minus 2 sin 30 times J hat. Vector B bar is equal to 2 cos 300 degrees times I hat plus 2 sin 300 degrees times J hat, which is equal to 2 sin 30 degrees times I hat minus 2 cos 30 degrees times J hat. And vector C bar is equal to 5 cos 120 degrees times I hat plus 5 sin 120 degrees times J hat, which is equal to minus 5 sin 30 times I hat plus 5 cos 30 times J hat.
There is one more method of calculating the components of a vector. I will review it now. Step 1. Draw a right-angled triangle with a given vector as the hypotenuse and the other two sides parallel to the axis. Step 2. The side of the triangle adjacent to the angle is cosine, and the side of the triangle that is opposite to the angle is sine. Step 3. If the component is in opposite direction as the axis, then the component is negative. Else, the component is positive. Let us find the components of the given vectors using this method. Let us take the vector A bar first. Step 1. Draw a right-angled triangle with a given vector as the hypotenuse and the other two sides parallel to the axis. Vector A bar is at an angle of 30 degrees and is in third quadrant pointing downwards. The x component would be along the negative x-axis, and the y component would be parallel to the negative y-axis. So as to complete the right-angled triangle. Step 2. The side of the triangle adjacent to the angle is cosine, and the side of the triangle that is opposite to the angle is sine. Here, the side of the triangle adjacent to the angle is x component. Therefore, the magnitude of the x component of the vector A bar is ax, which is equal to 2 cos 30. The y component of the vector is opposite to the angle, and hence the magnitude of the y component of the vector A bar is given by y is equal to 2 sin 30. Step 3. If the component is in opposite direction as the axis, then the component is negative. Else, the component is positive. The x component of the vector is along negative x-axis, and hence is given by ax bar is equal to minus 2 cos 30 times I hat. The y component of the vector is also negative, as the y component is parallel to negative y-axis. Therefore, y component of the vector is given by ay bar is equal to minus 2 sin 30 times j hat. Therefore, vector A bar is equal to ax bar plus ay bar, which is equal to minus 2 cos 30 times I hat minus 2 sin 30 times j hat. You can see that the result obtained using both the methods is the same. Can you use this method to calculate the components of other two vectors?
Yes, I will. The second vector B bar is in fourth quadrant and is at an angle of 30 degrees with y-axis, having a magnitude of 2 units pointing downwards. Therefore, the x component of the vector B bar, represented as bx bar, is along the positive x-axis. And the y component, by bar, is parallel to negative y-axis. The component adjacent to the angle is cosine. Therefore, the magnitude of y component is equal to 2 cos 30. And the component opposite to the angle is sine. Therefore, the magnitude of the x component is 2 sin 30. Since x component is along the positive x-axis, x component of vector B bar is given by bx bar is equal to plus 2 cos 30 times I hat. The y component is along the negative y-axis, and hence y component of vector b bar is given by by bar is equal to minus 2 sine 30 times j hat. Therefore vector b bar is equal to bx bar plus by bar, which is equal to 2 sine 30 times I hat minus 2 cos 30 times j hat. I see here that, for the vector a bar, the x component is given by the cosine of the angle, whereas for the second vector b bar, the x component is given by sine of the angle. So I believe it is not mandatory that x component will always be the cosine of the angle in this method, unlike in the first method.
That's a very good observation, and what you said is correct. This is an important point to be noted in this method.
Proceeding in this way, vector c bar is in second quadrant, directed at an angle of 60 degrees to x-axis, and pointing upwards. Therefore the x-component of this vector is directed along negative x-axis, and hence is negative. And the y-component is along positive y-axis, and hence is positive. Calculating the magnitude of the components. Magnitude of x-component is equal to 5 cos 60. And the x-component in vector notation is given by cx bar is equal to minus 5 cos 60 times I hat. And magnitude of y-component is equal to 5 sine 60. With its vector notation, cy bar is equal to 5 sine 60 times j hat. Therefore, c bar is equal to cx bar plus cy bar, which is equal to minus 5 cos 60 times I hat plus 5 sine 60 times j hat. Using the first method, I got c bar equal to minus 5 sine 30 times I hat plus 5 cos 30 times j hat. Since cos 60 is equal to sine 30, and sine 60 is equal to cos 30, vector c bar can also be represented as c bar is equal to minus 5 cos 60 times I hat plus 5 sine 60 times j hat, which is the same equation we got using second method. I see that both the methods yield same results. Now to add all the three vectors, we add individually the x components to get the x component of the resultant vector, and add all the y components to get the y component of the resultant vector. Therefore, if the resultant vector obtained by adding the three vectors, a bar, b bar, and c bar is represented as r bar, then r bar is equal to a bar plus b bar plus c bar, which implies r bar is equal to minus 2 cos 30 I hat minus 2 sine 30 j hat plus 2 sine 30 I hat minus 2 cos 30 j hat plus minus 5 sine 30 I hat plus 5 cos 30 j hat, which implies r bar is equal to minus 3 sine 30 minus 2 cos 30 times I hat plus 3 cos 30 minus 2 sine 30 times j hat.
If you find it easier to do the sum using tabular method, especially when the number of vectors to add is more. In this method, we draw a table where rows correspond to the vectors to be added and columns correspond to their components. In each row, we write the x component value under first column and y component value under second column. Finally, we sum up all the x component values present in the first column to obtain the x component of the resultant vector. Similarly, we add all the y component column values to obtain the y component of the resultant vector. I will explain this practically. First, we draw a table having 4 rows, each representing one of the given vector, A bar, B bar, and C bar, and the last one for resultant vector, R bar. Then we draw 2 columns, one for x component and another one for y component. Then, in the first row, write the values of x component and y component of A bar against corresponding columns. -2 cos 30, -2 sin 30. Continue this for remaining 2 vectors, B bar and C bar. 2 sin 30, -2 cos 30, -5 sin 30, 5 cos 30. Then for obtaining the resultant vector, R bar, add all the values present in x component column. Do the same for y component column. Therefore, x component of the resultant vector, R bar, is equal to -3 sin 30, -2 cos 30. And y component of the resultant is equal to 3 cos 30, -2 sin 30. Therefore, R bar is equal to -3 sin 30 -2 cos 30 times I hat plus 3 cos 30 -2 sin 30 times j hat.